right, we're going to go over multiplying binomials. This is a real-world application problem that we're going to start with and come up with a couple different methods on how to solve it. So our problem reads, the size of a family's rectangular table is 2 feet longer than the width of X. They want to buy a new table that is 3 feet shorter on each side. What is the equation to represent the area of the new table? So let's start by underlining some keywords. We have that the table is rectangular. So we are finding the area of a rectangle, right? The table is 2 feet longer. Longer meaning to subtract. Add. To add. Then the width of X. So you know that the other side is just so far X. They want to buy a new table that is 3 feet shorter. So 3 feet shorter, meaning to subtract. On each side. What is the equation to represent the area of the new table? So let's remember that when we're multiplying binomials, we are literally looking for the area of the rectangle in this problem. So we're going to represent that first by the area model for a concrete example of what this problem looks like. So first, let's set up our factors and what we're multiplying. Go back to our problem. It reads 2 feet longer than the width of X, so it's going to look like X plus 2. And the new table, they want to be 3 feet shorter on each side. So X minus 3 feet, right? All right, to show our area model, we are first going to create our square or our table right here. I'm going to use these areas just to represent our factors. So at the top, we're going to put X plus 2. And the bottom, X minus 3 or negative 3, right? So we're gonna whip out these area tiles. So let's go over what our area tiles mean. One big square is gonna represent X squared. And our red side is gonna represent negative X squared. This is 1x squared. Then our little long tiles are just going to represent X. This is negative 1x. This is positive 1x. Our little baby squares, they are going to represent just 1, a positive 1, and just a negative 1. So let's fill out our factors with our algebra tiles so we know what that looks like. So here we have 1x, positive x, plus 2, so positive 2, right? And then we have 1x, positive x, minus 3, so, or negative 3. So we're going to put our little negatives tiles here to represent that. All right, now we're going to multiply. We have x times x, which we understand is going to give us x squared. So we're going to represent that with our big tile. And now we are right here, and we're going to, we know that we have a positive 2x, so we're going to add those, positive 2x. And here we're going to represent our negative 3x. All right, now let's remember that we are looking for the full area of a square. This doesn't quite give us an area, right? We still have this missing little part. So what we do here is we fill this in with our baby squares. And we know that a positive times a negative is going to give us a negative, correct? So we're going to add in our negative 6 squares. Now here we have a representation, a concrete example of our rectangular kitchen table. Oh, oops. Right, our full rectangle. All right, so what we're going to do from here is actually create our equation. Oops. All right, so we know that we have our 1x squared, right? So x squared. Now we have this little issue here where we have 2 positive x's and 3 negative x's. Well, we know when we multiply a positive and a negative number, we will end up with a negative number. So let's create some 0 pairs to show that. We can create 2 0 pairs right here and right here, correct? Leaving us with our negative x, right? And then we show here that we have our negative 6 left over. So we got to add that to our equation, negative 6. So there's also another way to do it if 0 pairs confuse you. Let's add these tiles back. It's just a little simple step. And that's going to look like this. So back to, we know that we have 1x squared. Here you can write that you have plus 2x minus 3x minus or negative 6. And then we can use our prior knowledge of combining like terms, right? Leaving us with x squared minus 1x or minus x minus 6. And that is going to be our final answer. So this method, once again, was called our area method or our area model. All right. So let's go over another model. Now that you kind of have an understanding of what multiplying binomials actually means, there's a little shortcut. All right, let's rewrite our problem. We had x minus 2 and x plus 2 and x minus 3, right? All right, so now we're going to go over a method called FOILing. All right, this method, you literally just follow the acronym FOIL. So first is what the F stands for, outside, inside, and last. All right, so what this tells us is that first we are going to multiply the first x, so x times x gives us x squared, right? And then we're going to multiply the outside, so x times negative 3, negative 3x. And then we're going to go to the inside, 2 times x, which is positive 2x. And we're going to go to the last. Positive 2 times negative 3 is going to give us a negative 6, right? And then we're going to combine like terms, giving us once again x squared minus x or 1x minus 6, and that being our final answer. This method uses the distribution property of each number, which is always a great property to refer back to and remember. We have one more method that is a good visual method. It's called the box method. So we're going to add it down here. Box method. All right, so we have our problem, x plus 2 and x minus 3. And now we're going to draw a box kind of like we did at the beginning. Right? And since we're doing binomials, we have 2 and 2, right? Quads. So we're going to write our first factor at the top, x plus 2 or positive 2, and x minus 3 or a negative 3. Let's not forget when we were talking about negatives, this negative sign does have so many names, meanings, and things behind it, keywords to look for with that. Just don't forget this can mean a minus sign. This can mean a negative sign. We have some keywords like decrease by, shorter, like our problem, the difference, less than, reduce, and remove. These are all good keywords to look for in problems when it comes to whether we are going to be adding or subtracting integers, and so forth. Back to our box method here. What this shows is that we're going to multiply the boxes that line up, right? So x times x gives us x squared. And x times positive 2 gives us positive 2x. X times negative 3 gives us negative 3x. And 2 times negative 3 is going to give us negative 6, right? So here we can show our combining like terms by circling what we're combining. And we read it left to right, top to bottom. So x squared, and we have plus 2x, minus 3x, plus, minus 6. We combine our like terms like showed. We have x squared minus 1x or x minus 6.